Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about integration, something which is also known as anti-differentiation. So if you've seen the videos on differentiation, so you would understand what differentiation is. Well, anti-differentiation, it's, as the name suggests, is the reverse process of differentiation. So it's the reverse process of differentiation. So let's go ahead and get started, and let's try and understand what exactly anti-differentiation is, right? So the first of all, I'll say, let's suppose we have a function, right? Let's suppose the function is f of x. Let's say this function is anything; it could be anything, right? And when we find the derivative of that function, the derivative of that function is f dash of x. So I would say that dy over dx is equivalent to f dash of x. Now if I were to find the antiderivative of f dash of x, so if I were to say the antiderivative of f dash of x would be equal to f of x again, right? Because in differentiation I go from here till here, and in integration I go from here till here. So this is where I go from differentiation, and this is where I go from integration. So let's say, for example, I have a function, let's suppose f of x, right? And I say, let's suppose the derivation of a function is equal to 2 times x. Now how do you get 2 times x as your differentiation? Well, the function can be x square also, because if I differentiate x square, I will be getting 2x, right? It can be x square plus 5 also. It can be x square minus 3 also, because all these functions will give derivative as 2 times x. Even this will give us a derivative as 2 times x. Hence, once I have derivative of a function is equal to 2 times x, then these are all the possible functions or possible antiderivations of a function, of a derivative whose value is 2 times x, which means we will not be able to surely find out what is the antiderivative of this function. Why is that? Because the derivative of a constant is 0, right? Since the derivative of a constant is 0, and once we find the derivative of a function, we completely ignore the constants, which is why once we go back from the derivative to the real function, we kind of miss out on the constants. So constants are something which we miss out on. So let's suppose if I say that we have a function, let's suppose we have f dash of x is equal to 2 times x. That means the value of f of x could be x square plus a constant. So this is something which is a constant. This is something which is an unknown. We do not know what this is, right? Because, as again I've said in the example, the derivative of x square is also 2x, the derivative of x square plus 5 is also 2x, and the derivative of x square minus 3 is also 2x, and the derivative of x square plus c is also 2x, which means we do not know what is the value of this constant. So we're going to keep this as c here. Fine. So suppose you're getting this point over here, guys. Let's move forward and kind of generalize what we just said, that, right? So the anti-differentiation process. Anti-differentiation is just another name for integration, right? Now this is a process which can be summarized as below, that if I say dy over dx, the derivative of a function is f dash of x, then after anti-differentiating, the function will become y is equal to f of x plus c, right? So the function will actually become y is equal to f of x plus c, and all c belongs to real numbers, right? So we can say that y is the antiderivative of f dash of x. Fine. So I suppose you're understanding this point over here. Now there is a different way in which you can denote it, right? So you can actually denote this y as an integral sign. So the set of all the antiderivatives. So set of all the antiderivatives of, let's say, any functions, right? So all the antiderivatives of any function, let's suppose h of x, right, are actually denoted by this sign over here, which is the integral sign, and are all called as indefinite integral. So they are all called as indefinite integral, right? And this is something which is denoted as the integration of h of x dot dx, right? So from here I can actually get any function, right? So that would be the antiderivative of h of x plus a constant, and in this case this is known as the integrand, and x is the variable of integration. So these are some of the important things that we would be discussing on, right? So let's suppose when I say what's the variable of integration, that would be x because of this dx over here, and this integrand is h of x, the one which is getting integrated, right? So in this case, f dash of x was the integrand. From there, we were actually going to fx plus c. So suppose you're understanding this point over here. Now, if I were to denote it completely, I'll say the integration of the antiderivative of h of x dot dx is something which is the original function h of x plus c, such that c belongs to real numbers. So suppose you're understanding this point over here, and we can also call this as the antiderivative, or we can also call this as the indefinite integral. Fine. So I suppose you're understanding this point over here, guys. Now let's go ahead and try to find out the integral of, so if I talk about the integral of x to the power n dot dx, right? So if I want to find the integral of x to the power n dot dx, I'll have to find a function. So this should be a function whose derivative should be this, right? So there should be a function whose derivative should be this. Now let me go ahead and take an example here. Let's suppose if I have a function h of x, and let's suppose this is the derivative of that function, right? So this is a function x, the derivative is going to be 1. The function x squared, the derivative is going to be 2x. The function x cubed, the derivative is going to be 3x squared. X to the power 4, the derivative is going to be 4x cubed, right? So let's suppose if I have x to the power n here. So as you can see that when this is of, the derivative of x to the power n is n into x to the power n minus 1. So this is how the derivative goes, right? But what about antiderivative? So that means if I want to find out the antiderivative of this, that is n into x of n minus 1, that will actually be equal to this, because I'm going from here to here. So that will actually be equal to this. And if I say, let's suppose n minus 1 is equal to p, which means n is equal to p plus 1, that means this is something which can be transformed into p plus 1 into x to the power p is equal to x to the power n, which is actually p plus 1. So which means I can say that the antiderivative of x to the power p dot dx is actually equal to x p plus 1 divided by, this is a constant, which means I can actually take it to that side, which means this is going to be divided by p plus 1. So that means I can say that the antiderivative of x to the power n dot dx is actually equal to x to the power n plus 1 over n plus 1 plus a constant. So adding a constant is necessary. It's important because this is a possible antiderivative. So this constant can actually take any values. Fine. So suppose you're understanding this point over here. And over here, understand one thing is, this is something which is true as long as n is not equal to 1. Right? So this is something true as long as n is equal to 1, not equal to 1. Sorry, n is not equal to negative 1, because we don't want this to be becoming 0 and we don't want this to be becoming indefinite. Well, we'll come to the special case when n is not equal to minus 1. We'll talk about this in another video. But for now, this is what you're supposed to learn. That is that the derivative of x to the power n naught dot dx is equal to 1 over n plus 1 into x to the power n plus 1 plus c. And if I multiply a constant with it, let's suppose the derivative of a into x to the power n dot dx, that means this constant will just come out here, because the derivative of antiderivative of constant is it's something which we will not be doing here, right? So that means this is the constant will just simply get multiplied, and this is what I will have, right? So the constant will just simply get multiplied. So suppose you're understanding this point over here, guys, right? So let's suppose if I want to find out the antiderivative of 4x squared. So that is going to be, so 4 is going to be out. Then I'm going to have this as x squared. That means n is equal to 2. So this is going to be 1 over n plus 1 into x cubed plus c, right? So this is going to be 4 by 3 x cubed plus c, and c belongs to real numbers. Fine. So suppose you're understanding this point over here, guys, and again, even if you kind of differentiate this, let's suppose if we differentiate this, what is dy over dx here? So that is going to be 4 by 3, and if I differentiate this, this is going to come down to as 3x squared, and plus the differentiation of a constant is 0. That means it's going to come down to 4x squared, which is nothing but the same thing. Fine. So suppose you're getting this point over here, guys. Let's try another question. Let's suppose if you want to find the value of this. So again, this is going to be 1 over n plus 1 into x to the power n plus 1 plus c. So this is going to be negative 1 over 2 into x to the power minus 2 plus c, which is actually going to be equal to negative 1 over 2x squared, because this is negative 2, so it will come down to the power here, plus c. So suppose you're getting this point over here, guys. Now let's suppose if you want to find the derivative of square root of x of 2x, which is actually equal to x raised to power 1 by 2 dot dx. So that is going to be 1 over 1 plus 1 by 2 into x to the power 1 plus 1 by 2 plus c, which is going to be equal to, so this is going to be equal to 3 by 2. That means this 2 will go up, and we'll have 2 by 3 into x to the power 3 by 2, right, and plus c. Fine. So this is going to be the antiderivative of this function over here. So suppose you're understanding this point over here, guys, and suppose this is the introductory video on integration. So thank you very much for watching this video, and I suppose I've laid down the basics of integration for you and opened up a whole new world of calculus for you. So in the next videos, we're going to be talking about various in the next video, we're going to be talking about various points, various parts of integration, and we're going to be moving forward in integration. So before we go forward, guys, make sure that you know this website, you like us on Facebook page, and give us your valuable feedback. So thank you very much for watching, guys. I'll see you in the next one.